All right, so you got number 8, and all these different elements that you need to be able to identify from your properties of metals lab that we did as a class as we moved around all the furniture to create a lab setting. So, and took some data on different substances to determine if it was a metal, non-metal, or metalloid. So that's what we're going to do using this data. So based on the data below, classify each of the 8 elements as metal, non-metal, or metalloid. So we've got letter A. Here, I'm going to give you a couple tricks as we go. We've got letter A is malleable. It conducts electricity, yes. It's gray and shiny. At that point, knowing those 3 things, you know that metals are malleable. Metals will bend. If you hammer them, they will bend with the different atoms. So that in itself, just knowing those 3 items, you can also look at here. There's going to be some times that you have a metal that does not necessarily react with water. So for example, aluminum did not react with water, but aluminum did react with hydrochloric acid a little bit. So knowing these 3 things, malleable, yes, and it is gray and shiny, you would then indicate that it is a metal. And we got letter B, we've got brittle. Yep, it's brittle, so this is already, you can say it's not a metal. So if it's brittle, meaning it shatters everywhere. Then if it conducts electricity, yes, it conducts electricity, and this would be actually conducts electricity just a little bit. So that would be just a little tiny, tiny bit. So if it's a yes, it's brittle, gray and shiny, and it does not react, that should be an indicator that that is a metalloid or a semiconductor, if you'd like to write that. Then we've got C, it is brittle. It does not conduct electricity. So if it does not conduct electricity and it has a color that is not gray, sometimes it's going to be a solid. So if it's brittle, remember the metalloids take on the properties of nonmetals when it talks about malleability, and then it also takes on this role as a metalloid. So this one here, we've got brittle, and it's not going to conduct electricity. So if it does not conduct electricity, it is going to be a non-metal. And then letter D, we've got brittle. Yes, it's dark gray. It's a solid. Also does not react. Just think for a second. It's brittle, conducts electricity. These 2 kind of in the same boat. It's also a metalloid or a semiconductor, however you'd like to write it. And then letter E, we've got it is malleable. It conducts electricity. It's silver shiny. So remember that if it's malleable and it conducts electricity, you certainly have a metal. This means that it is bendable. It bends. And then malleable or brittle, if there's no data, meaning that there is no way that it will bend or break, means that most likely it is a gas. You can't hammer it because the hammer will not hit the gas. So it is colorless. Guarantee on that one that if you want to get specific, you'd say it's a noble gas, but all at this point that I'm expecting is a non-metal. This one, again, so I'm going to scoot that up a little bit. It's going to be brittle. Does not conduct electricity. It's dark purple. Also, it's not going to be reactive, so there's something. So occasionally you're going to end up with a non-metal like iodine that is a solid. So this one also, because it does not conduct electricity and it is brittle, is going to be a non-metal. And then last but not least, you got H. It is malleable. It conducts electricity. It is orangish though, but it does react with hydrochloric acid. So even though it is orange, if it is malleable and it conducts electricity, most likely you do have yourself a metal. So I'm going to scoot that down a little bit, and that should be a metal. All right, I'm going to scoot on the back side. This will hopefully help you out. So the back side is going to be where you're looking at your periodic table notes. And actually, go ahead and just, if you are interested in knowing more about this one, go ahead and click the next video, because I think that this video is playing long enough, so I will show you what we got so far. So, all right, here we go.